Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic and usually on location. Each time we meet, we bring together a group of IT luminaries to discuss a single concept relevant to the data center today. Today, we're talking composability and how composability is just ready to swoop in and save the data center from the cloud. First, let's meet our guests.
Hello, my name is David Klee. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert, and I am the founder of Heraflex Technologies.
Hello, everyone. My name is George Wagner. I'm a Novell 4.0 CNE and currently run tech and product marketing for Liqid.
Hi, my name is Frederick Van Haren. I'm the founder of Highfence, which is active in the HPC and AI markets, and my background is in speech technology.
So all of us are part of the AI Field Day event, and we heard Liqid present a composability for AI applications, and that's all well and good, but I think a lot of us are thinking, wow, this is how everybody thinks computers work and kind of how computers might work in the future. And I think one of the things that people love about the cloud is sort of the dynamism of being able to have basically software-defined infrastructure. Seems like composability is doing that. George, maybe you can kick us off by just sort of what is composable infrastructure and why should we be excited about it?
Sure. So I kind of like taking it a step back and say, okay, for the last 15, 20 years, we've been using great software like virtualization and more recently Kubernetes to take it and make our hardware easier to provision, easier to scale, easier to manage. But underneath that, we've still been that's all consuming the same kind of static hardware that's been in existence for 30 plus years. I was in IT in the 90s and early 2000s. It really hasn't much changed except for just faster and bigger. It takes a long time to deploy. It's difficult to scale, and it's not very efficient. Those are three areas where the cloud has excelled, right? So what composability does is it enables folks in the data center, and earlier today talking about AI and HPC, allowing those organizations to essentially create bare metal servers to meet any workload need via software. And scale just as simply as you can in the cloud, but be able to do it on-prem, the edge, and we even have data center cloud customers who use this as their infrastructure.
Yeah, I totally agree with that. I think if you look at the public clouds, that's exactly what they're doing for you. They present to you a composable framework where you compose how big your local disk will be, what the resources are. And that's one of the selling points of the public cloud. And a lot of people find that very attractive. And, using Liqid kind of gives you the ability to do it all yourself. I mean, one of the challenges you have certainly with AI workloads is that they're not all the same. They all require a little bit different. And that's where composability in general makes it very, very useful. And then secondly, there's always the acquisition cost, right? A lot of people want to go to the public cloud because they prefer the OpEx model versus a CapEx model, which is really understandable considering the evolution of how fast the GPU cards evolve and GPU technology evolves to the point where the depreciation, meaning the CapEx model really doesn't fit the bill. So having the ability to use composable technology to create a higher efficiency of your investment is definitely a plus.
That's the biggest thing. For me, it's the efficiency and the speed of being able to change the environment as you need it. Cloud, you see it all the time. People go there. It moves at the speed of business, not IT, because IT has historically just been a real pain. You need a new server, even in VM. You put in a provisioning request. It takes them a week to get to it. There have been a lot of attempts to automate and streamline on-prem operations, but none of them have really gotten there. I mean, look at the attempts over the last 10 years. They fall flat. There are a few recently where you can do cloud-based automation on-prem, but you're still limited by the hardware that you're on. I love composable infrastructures because now I can move the infrastructure at the speed of business because it's possible. It's never been possible before.
But let me be the devil's advocate here. As a longtime enterprise tech guy, frankly, a lot of this sort of dynamism in the data center is maybe oversold. I mean, I don't remember it being a problem to not be able to reconfigure servers dynamically. I mean, maybe I'm just an old coot, but do people really need to dynamically recompose and reconfigure and restructure their servers in the data center, or is that just more of a cloud thing for all these young whippersnappers?
I claim they do. In my world, I move data around a lot. I need to validate data. I need to process it in certain places. And quite frankly, it's not the act of changing just to make change. It's the act of, I need a ton of compute right now over there. And then I'm going to move the data over here. And now I need a ton of RAM so that I can analyze it. And I need really fast storage so that I'm not waiting a month to analyze it. But then when I'm done processing it, all that can go back to the pool for another week or month or whatever the window is that I'm processing on. And to be able to essentially do what virtualization did a couple of decades ago, but do it better, I'm making more and more efficient use of a more tightly controlled set of compute resources. I'm able to be more efficient with it, more strategic with it. Move it around where it's needed, pull it away when I'm not.
I think it's also how hardware is purchased today, right? I mean, years ago, people would have an application, they would have a need, and they would size it and then buy a specific piece of hardware. And that specific piece of hardware would be redundant once the application was not being used anymore. Now, although hardware is generally cheaper, there's also more need to do processing, right? So AI is a good example where a few servers isn't enough to do reasonable AI. You need a much larger amount of hardware. And so you start to change your purchase behavior where you buy many more servers of the same. And in some cases, you keep your old server. So you end up with a situation where you have a 3-year-old, a 2-year-old, and a 1-year-old rack of servers. And all of that needs to work. So I do think that also the purchasing and the way people purchase hardware has changed.
Yeah, or in my world, the business has changed so much that the hardware they spent a crazy amount of money on 6 months ago isn't keeping up. We've got companies that buy other companies. We've got data demands that are going through the roof. We've got analytics that are coming out of nowhere to reprocess data that they've been looking at for years just in a new way. I need that flexibility because it's a lot easier to adjust a composable environment than go buy another 90 or 100 core machine, spin it up, rack it, burn it in, migrate everything over just to be able to do it again in 6 months to a year.
Yeah, and I would say, in the last year, obviously with COVID, everyone's working from home. Oh, I'm not. I'm actually been in the office for about a year now. But it's changed the way a lot of people are working. And when you have knowledge workers who need to do work from home and they require perhaps GPU, as an IT guy, you don't have to go out and re-outfit your data center with new servers. Why not just go out and get GPUs and compose them into the servers you have? And so we've talked to a lot of customers who made those investments before COVID, and they don't want to go out and buy. They've actually done it with blades, so we can actually plug into blades as well. So it's not just about building new servers, but as you both mentioned, it's about kind of changing the buying habit from everything being focused around purchasing a CPU with all the other hardware around it, and just buying the resources you need now when you need them, and composing them in and pulling them out when you don't.
It's all about the change. I mean, in IT, the only constant is constant change. And to have an environment that can change with the business instead of fighting it at every tooth and nail, I love it. I love the concept. I can't wait until we can really see much more global adoption of this.
But I mean, doesn't this sound like the pitch for virtualization? I mean, you want flexibility. Okay, well, that's what the hypervisor's for. That's what everybody's using in the data center. I'm going to wear out my devil's advocate shoes here. How about we just virtualize? Oh, wait, we already did. So is this really a compelling option?
Sure, because if I buy equipment today, 6 months from now, if the workload is doubled, does the platform that the virtual machine resides on, does that have enough compute resources? Most of the time, I'm not able to go comfortably or easily add a handful of CPUs or another GPU or some faster network adapters easily. With composable infrastructure, buy another tray of disks, buy another tray of memory. Simply link it up, expand into it.
And this is another great advantage of it is that you know what happens when in a traditional infrastructure with virtualization when you run out of capacity, compute or storage or accelerators, you need to buy another server. And when you do that, you get more sockets. And when you have more sockets, you got more license. So if I can just add resources into my existing server, if I'm not compute constrained from a CPU perspective, I can add any resources I need to it and save the VMware tax, so to speak.
It's not just VMware. Look at relational database licensing is usually by the core. What if I need more RAM and not more cores? You're stuck.
Yeah, I do think it creates an abstraction layer also for people consuming the infrastructure, right? So in AI, you might start small and you might need to add more resources to it, and you can do this in a dynamic fashion such that you don't really need to reach out to an IT person to help you and reconfigure the hardware. So, I mean, kind of referring to what Stephen said earlier about virtualization, I think virtualization was one of the first few steps towards this kind of model, right? And the model will keep on evolving to the point where you can just buy a bunch of hardware and then you can slice and dice it the way you want it. And then you obviously, it's not just an infrastructure perspective. You need to slice and dice and provide the capabilities from a software perspective as well, which is, Kubernetes comes into play, and that what Kubernetes helps you kind of look at the changing hardware platforms, or at least what it has access to, and then says, okay, now I can deploy my Kubernetes cluster. Here's what I can, the pods I can deploy, here are the applications, and keep on doing that. So I think it's just an evolutionary process.
Exactly. I mean, I look at the big iron servers as an evolution beyond mainframes. Virtualization is just mainframes with commodity equipment. Containers is the next evolution of virtualization, just literally virtualize it without the OS. And now this is a really good next step beyond that. So it's beyond virtualization. I love it.
So to put on my devil's advocate shoes, I know this is going to be unusual for you to hear. How about the cloud? I mean, is the cloud supposed to be this? I mean, the cloud is going to save the infrastructure, because instead of having to buy things, you can basically go rent whatever you need whenever you need it, use it for as long as you need it, and then you're done, right?
What if you need it for more than a few minutes at a time, and that nifty little thing called a credit card comes due? Cloud is a fantastic tool. It's a wonderful use case when the tool requires that level of abstraction, or maybe the business case is, I need something right now. I spin it up for a day or two. I tear it back down. No problem. When you look at the economies of scale with on-prem and a lot of these really high-powered use cases, you're spending an order of magnitude more in the cloud than if you did it on-prem. I love the cloud. To me, cloud is virtualization with really good automation on top in somebody else's data center. But when I'm looking at these big environments that I need all the time going forward, even though I need to move stuff around, it's a whole lot cheaper to do it on-prem.
Yeah, I would say two things. I think that both virtualization and the cloud were reactions to the fact that data centers are inefficient, slow, and hard to scale. Right, that's part of it. So those are both reactions to that. However, there's also the security part of things, right? In the cloud, you don't have control, right? So you look at what happened to Parler within AWS. I talked to a lot of the analysts frequently. They said that the number of phone calls they had with their larger clients who are trying to find ways to get out of the cloud have grown exponentially since that particular event occurred. So this, we have these conversations. It is kind of like, okay, what is it? Okay, well, basically, imagine you have cloud benefits on-prem, as far as quick to deploy, quick to scale, efficient, and by the way, it's yours. Oh, okay. interesting. But yeah, those are the two things I would say.
Yeah, I think the public cloud is great for standard resources. And as David said, anything you need for a longer period of time, it's not a technical question, it's a cost challenge. But another reason why staying on premises and using composable technologies is data gravity. I mean, in the end, you're still moving data around, and although the public cloud provides a lot of flexibility, there is a significant cost for moving data between regions, egress, or actually multiple clouds. And in some cases, you don't have a choice, right? So sometimes you might need to change geographical location for GDPR, whatever the reason. And in the end, if you have something more composable, you have more control over your destiny, not only from a technical perspective, but also from a cost perspective.
All right, so we've decided that this makes sense in the data center, and we've decided that it has some advantages over virtualization. We've decided that it even has some advantages over the cloud. What are the proper applications for this? What are the ideal use cases for composable infrastructure? I mean, certainly we heard about AI today, and I think a lot of people can get on board with that, because I think a lot of us are used to the challenges of trying to plug in enough GPU resources where we need them in order to do model training or something. What else is composability useful for?
I can see it as really the modern data center. Essentially the business is always changing. So dynamic environments, hosting providers, businesses that have a lot of growth, anything that's dealing with large volumes of data, moving data around, processing, analytics, anything where you're dealing with large sets of stuff, processing, compute, anything like that, especially where you may only need it for short periods of time, but you need it on a good periodic basis.
Yeah, I would say I would absolutely agree with David. And kind of like we talked about this earlier, Stephen, is I think many of the general purpose data center use cases are kind of downstream from, AI, HPC, et cetera. I think you're going to see it become more commoditized over time and move into general data center. We've been talking to customers who are interested in this for, any use case. And it's, from databases, virtualization, AI, even at POC prototype levels for smaller organizations who are looking to start something small and grow it. But yeah, I see this really being something that's going to become ubiquitous here in the next few years. I mean, it's still pretty new, but it'll take a little bit of time. But I see this. I'm pretty convinced it'll be such.
Yeah, I think it's also, besides the dynamic applications, which doesn't have to be AI, it's also the ability to share infrastructure across the organization. Not every piece in the organization needs infrastructure, 24/7. Some of them might need something for a couple of days. I'm just thinking, my experience every time it was the end of the quarter, there's a lot of spreadsheets action going on and a lot of number crunching where the Oracle systems were then hammered, and it would have been nice, I guess, for them if they had some kind of flexibility where they could expand a little bit their Oracle environment and then reduce it afterwards. So I think it's flexibility, dynamic behavior, but it's definitely not limited to AI. I think AI just by nature is a perfect fit. But I think in general, anything that is dynamic will take advantage from composable.
Yeah, I'd say anything that's dynamic and that's aggressive in its resource consumption. We've got some environments, the American holidays go crazy with, capitalism, and watching the way their systems just get abused for 2.5, 3 months out of the year. And the rest of the year, they're nice and quiet. They can repurpose that, do other things with it, scale it back down accordingly.
But isn't that right there just the argument for the cloud? I don't know. Maybe enough of the devil's advocate stuff.
It's a great use for the cloud until you start looking at the price tag. And when you hit that level of scale, it's cheaper. It's order of magnitude cheaper to stay on-prem and have the staff that know how to manage it, for the pieces that you still have to manage.
Yeah, it strikes me that the cloud is amazing for workloads that are smaller than a machine, but becomes challenging for workloads that are much, much bigger than a machine. And so for a normal human, and for normal people's applications, the cloud is incredible. But once you start getting really big, it starts getting beyond the capabilities there, and you start choking on the price. But it occurs to me too that this is the direction the industry is heading in. We've heard about CXL, and we've heard about the fact that next generation servers are going to have this new capability, but I'm not sure people are really aware of what that is. I wonder, I don't know, George, if you're the right person to say it, but sort of what is coming down the pike from the next generation of infrastructure, not specifically Liqid, but sort of compute infrastructure?
Sure, yeah. I think there's, it's, for those who don't know, a lot of what makes composability work under the covers is PCIe, right? It's PCIe bus. Essentially, what's happening is, we're extending the PCIe bus outside of the server and across the data center. Essentially turning the data center into a massive, compute pool, right, and storage pool, and that only became possible with PCIe Gen 3, and so that's 16 gigabytes per second bandwidth. And Gen 4 is even better, right? So 32 gigs per second. But with Gen 5, we're now at 64. And that unlocks a whole new level of possibility around cache coherency, in the ability to do things like compose memory. Because the one limitation that composability has across the industry is that you cannot currently compose RAM, right? It's your compute element is CPU and memory. What CXL will allow you to do is have a compute and memory, but have a small amount of memory on the server. And then with CXL, it's called Compute Link Interconnect. And it rides on PCIe Gen 5 and includes like 3 protocols. I think one is for IO, right? So CPU, one's for cache, and one's for memory. So allows coherent memory access. And what that's going to allow people to do is take and create and they'll have pools of DDR5 memory in their data center that they can then take and compose into the servers. And once that happens, it's going to be crazy. But that's for those of you who have maybe heard the term CXL. That is what it is. It's not part and parcel from Gen 5. It's part of Gen 5. It rides the technology, and that's really going to open up a lot of opportunity.
Have David and Frederick, have you guys heard of what's coming down the pike with CXL, or is this news to you?
I've heard pieces of it, and I've done a lot of research and R&D, and I'm really excited about it, mostly because it is, in my opinion, the future of the modern data center. I love the fact that we can now add what we need right before we need it, and we're good. I love it.
Yeah, I think I think it's more important sometimes to have more access to memory than to storage, right? And I think, and to be honest, I almost look like storage like a secondary tier compared to memory, right? So ideally, the holy grail is that storage doesn't exist, but that you have enough persistent memory in your server that you never have to reach out to something else. So it's obvious that something had to gravitate towards something where you had access to more memory in a server. I mean, to a certain degree, I think some AI workloads are actually split across multiple servers, not because they wanted more CPU processing, but just they wanted access to more memory. And for that reason, they were splitting their workloads into multiple servers. So I do think that's moving in the right direction, right? I definitely want to see 10 petabytes of memory accessible in a single server. I would definitely know what to do with it. But I think that's really where the next, call it the bottleneck if you wish, We at some point CPUs were kind of relatively slow compared to GPUs, FPGAs. Then storage, we had the spindles, we had flash, SSDs, NVMEs, and now I think it's the time for memory to get this time under the limelight.
That's a great point.
Yep. Move the bottleneck further up the stack and expand as needed.
Well, that's just the story of enterprise infrastructure, computing infrastructure, isn't it? Just moving bottlenecks. That's all we do. We move bottlenecks here or there or somewhere else, and eventually we'll encounter it again and have to move it yet again. So
keeps you on your toes, right?
Well, honestly, all this stuff keeps you on your toes. So what do you think? Our premise today was that composable infrastructure was going to save the data center from the menace of the cloud or the menace of whatever. Do you think that's going to happen? Let's start with David this time.
I think it is, because the act of having the automation in the cloud has now become front and foremost in people's minds. They love the automation, but then look at the price, look at the data proximity, look at the locality, look at the act of moving the data around. I need that flexibility on-prem. To me, just like George said, virtualization was a really good response to that. I think this is the next logical evolution of that response.
How about you, Fred? Does this make sense to you?
Yeah, I do. I mean, I think the public cloud showed us that with a lot of automation, you can make it a lot easier to consume, right? Let's ignore the cost perspective to it. At the same time, the reality is that if you are very intensive or have very intensive workloads and you run for a long time, it's not the automation that is going to kill you, it's the cost to it. So I do believe that on-premises solution or evolution of on-premises solutions like composability on-prem is the right way to go. And again, it's an evolution, right? It's not an end point. We're just in a journey where everything is moving forward. But there are cases where public cloud is good. There are reasons why you would stay on premises. There are reasons why you would leave on premises. So there's a little bit for everybody. But I do think if you talk specifically about AI, the tendency would be to go on premises with composability.
Excellent. And George, last word?
Yeah, so I'm pretty much a cynic. I always have been, but I really believe that this is kind of the great equalizer. The cloud's not going away, but I think this will create some level of parity from a flexibility and agility standpoint that gives people the opportunity to put their infrastructure on prem when it makes sense and put it in the cloud when it makes sense, but do so for reasons other than being on-prem stinks, because it's just a pain in the butt,
Well, thank you so much. Thank you, everybody, for joining us with the episode of the On-Premise IT Roundtable podcast. Let's go around the corner here and see where can we connect with you and learn more and continue the conversation. Fred?
Yeah, so you can always find me on Twitter or LinkedIn. I work mostly on data management items with customers, and I'm a frequent. I guess now I can say I'm a frequent podcast presenter on AI utilities. So,
how about you, George?
Yeah, so you can find me. I'm not on Twitter, but you can find me on LinkedIn, GR Wagner. You can also find me at liquid.com. I've written plenty of blogs in there and hope to be on more of these with Stephen going forward. I've done them in the past and I love them.
Yeah, and you can find me out at Twitter. My if it hasn't been obvious already, my handle is Klee Geek because I wear that moniker loud and proud. I'm on LinkedIn at David A. Klee, and you can catch my infrequently updated blogs at davidklee.net and heraflux.com.
And I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. You can find me on most social media networks at sfoskett. You can also hear my podcast, Utilizing AI, every Tuesday. And, of course, the On-Premise IT Roundtable, which I co-host with my compadre, Tom Hollingsworth, on Tuesdays as well. And, of course, on Wednesday, you can join Tom and I for the Gestalt IT Rundown. So thank you very much for joining us for this episode of the On-Premise IT Roundtable. If you enjoyed this discussion, please do subscribe, rate, and review the show, but more importantly, please share it with your friends and other geeks like us. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks for joining us, and we'll see you next time.